Hello everyone, welcome to the 5th video of my YouTube channel, Data Science with Sam. In today's video, I'm going to talk about how to perform linear regression using a very popular R programming language. In the previous video, I talked about the basics of linear regression and how you can perform a very simple single linear regression using Microsoft Excel. So let's take a look at the equation that we discussed in our previous video. The equation was y equal to mx plus v, where y is nothing but the dependent or the response variable. X was the independent variable or the explanatory one. M was the slope and b was the intercept, right? So today I'm going to talk about one more parameter, regression residual, before I dive into the R programming example. The term residual means it's a vertical distance between a data point and the regression line. So that means it tells you how much the data point deviates from the regression trend line. Each data point has one regression residual. Sometimes it could be positive if the data point is above the regression line, or it could be negative, it's below the regression line. Before moving on to the R programming section, let's talk about two statistical measures that will be useful to validate the accuracy of model in the later sections. One is p-value, another one is R-squared. So p-value is kind of a measure that's been used in the hypothesis testing to help the model to support or reject null hypothesis. The smaller the p-value, the stronger the evidence that it should reject null hypothesis. It provides randomness of the model. Like suppose if the p-value is 0.02, that means there are 2% chance that the model should produce random results. The p-value is 0.19, that means a 90% chance that the model would produce random results. As far as the statistical measure concerned, we consider p-value 0.05 as benchmark. That means if a model would produce less than 0.05 p-value, that means the model basically has a 5% chance to produce random results, and we consider this more significant. And usually we use those kind of model with p-value less than 0.05 in real-life applications. R-squared is another statistical measure of fit that indicates that how much variation of the dependent variable explained by the independent variable. It evaluates that how much the data points are scattered across the fitted regression line. In most of the cases, the model evaluates the performance based on the R-squared value. The value ranges between 0 to 1. If R-squared value is 0, that means model does not explain any variation of the dependent variable. If it is 1, that means it's explained all the variance of the response variable. In most of the cases, the bigger the R-squared value is, the better the model would be to predict the response variable. Those of you who already worked on R programming language must be familiar with the software RStudio, which you usually use to run R code. So here in the RStudio screen, I'm showing an R code which you can use to perform linear regression using a Boston dataset, which is kind of part of R's inbuilt library mass. The Boston dataset is nothing but having 13 variables which you use to predict median house value of a certain location. So let's check out the variables and their correlationship. So as you can see, some of the variables are positively correlated with median house value, and some of the variables are negatively correlated with them. Like suppose for this one, LStat, this variable is correlated with median value, but it's negatively correlated. So the next step is to to split the data into train and test data set, and then use R's inbuilt LM function to build the model for linear regression. And the next step is just to check the summary of that particular model. As I mentioned in the previous section that R-squared and p-value are the two main statistical measures to perform the accuracy of the model. So here you can see this particular model does have less than 0.05 p-value. It also shows 0.5517 R-squared, which moderately is okay. And apart from that, this particular summary will also show you that how this predictor variable is related with the median house value. As you can see, this negative sign is showing that the LStat variable is negatively correlated with median house value. Now let's check out how we can plot it. So if you can plot this linear regression, you will find this particular graph where it's showing that all the values are kind of trending downwards. So that means if you increase the LStat value, the median house value will decrease, and the trend line is going downward. In additionally, if you want to predict using the model, you can also use that using this particular code. That's all for now. If you really want to see the code, you can visit my GitHub link, which will be mentioned in the video caption. Thank you. That's all for today. Please look down in the video caption as there are more materials related to linear regressions are mentioned there. And don't forget to visit my GitHub link to check the R source code. In my next video, I'll talk about linear regression using Python. So it will be very intriguing for the Python users. And don't forget to subscribe to my channel because more contents are forthcoming. Thank you. Till then, goodbye.